This is Algebra 2, Unit 3, Lesson 5, Systems of Equations in 3 Variables. And we had talked about earlier in the chapter that if you're trying to solve equations that are in groups, like if you want to solve a system of equations in 2 unknowns, in order to do that you have to have 2 equations. If you want to solve one with 3 unknowns or 3 variables, you have to have 3 equations. 4 unknowns or 4 variables, 4 equations. So the number of variables that you have is the number of equations that you're going to have to be given in order to be able to solve them. And a calculator can be used for all of these. I've seen calculators go up to as many as 6 variables. So really doing it by hand is a bit redundant, but I'm going to show you how it's done, and then I'm going to show you some other methods for solving these that are a bit easier. But I think it is important for you to see how elimination and substitution are used together to do this by hand. So that's what we're going to do first. Now with these equations, notice I have an x, y, and a z. So I have 3 variables. Those variables can be anything. They could be a, b, c, e, d, f. It doesn't matter. When I show you how to do this in Desmos, though, you want to use x, y, z no matter what. So if they give you a, b, c, I would say let a be x, let b represent y, and let c represent z, so that you have it in Desmos for something that Desmos is going to recognize. But if I'm going to do this, the first thing I'm going to do is I want to eliminate one of the variables from all 3 equations first. If I do that, then I can solve it using systems of 2 equations, and it makes the math a lot easier. So what I'm going to do is I'm going to look at the x and the y's and the z's, and I'm going to determine which one would be the easiest to get rid of or to eliminate. And if you see here for the x's, this one's 1x, I've got 2x and 2x. For the y's, I've got 2y, a 1y, a -3 or a 3y, and z's, I've got a z, a 3, and a 5. Well, I'm going to eliminate my x's because it's a lot easier to get all 3 of those to be the same or opposites. It doesn't really matter. You can do the same or opposite. It just depends on whether, if they're the same, you would subtract to get rid of them. If they're opposites, you would add to get rid of them. So I'm going to multiply this equation by a 2 so that I can force all of my x's to be the same. Okay? And once I do that, I'm not going to worry about that top equation anymore. I'm going to now consider it having a 2 in front of the x. So if I do that, I have 2x plus 4y plus 2z equals 20. Make sure you do multiply by 2 to all 3 of the terms on the left and to the term on the right. If you don't multiply everything by that 2, you're going to change the value of the problem and you'll get the wrong answer. Okay, so now I'm not even going to worry about this equation anymore. I'm going to now use these equations. And what I'm going to do is I'm going to pick 2 equations at a time, and I'm going to eliminate the x value. So I'm going to take the top 2, and I'm just going to rewrite it. 2x minus y plus 3z equals -5. And then the middle equation, 2x minus 3y minus 5z equals 27. And I'm going to eliminate the x from those top 2 equations. So if I eliminate the x, I'm going to subtract everything on the bottom from the top. So 2x minus 2x is 0. -y minus -3y is a 2y. 3z minus -5z is 8z. And that equals -5 minus 27 is -32. Okay? Then I'm going to go over here and I'm going to take the bottom 2 equations and I'm going to do the same thing. I'm going to eliminate x. Remember, you have to eliminate one of the variables first in all 3 equations, then you'll have something you can work with. So in order to eliminate these 2, I'm going to subtract again. So I have 2x minus 2x is 0. -3y minus 4y is -7y. -5z minus 2z is -7z. 27 minus 20 is 7. Okay, now look at what you have. You have this equation and this equation, and they both have a y and a z. So now, using these two equations, I have a y and a z. I'm going to pick either y or z and eliminate that one out of those two equations, because remember, if you have two unknowns, as long as you have two equations, you can solve those equations. So if we look at this, this has a negative 7y, this has a 2y. So I think it would be pretty easy if I multiply this one by a 2 on both sides, and I multiply this one by 7 on both sides, I'll be able to eliminate the y. So let's do that. 2 times negative 7 is negative 14y. 2 times negative 7 is minus 14z. 2 times 7 is 14. And then here, 7 times 2y is 14y. 7 times 8z is 56z. And 7 times 32, that's a negative 224. Then, if you look at what you've got, those are opposites. So that means I'm going to add those together. When I add those together, those cancel. Negative 14z plus 56z. So that's going to be a 42z. And then 14 plus negative 224 would be a negative 210. Then if I divide by 42, I get a negative 5. So z is negative 5. Okay? Well, now that I know what z is, I can then take that z value and I can plug it back into this equation that only had two unknowns. So let's do that. I have 2y plus 8z equaled negative 32. I'm going to plug z, the negative 5, in for z here. So I'll do some substitution. So 2y plus, let's see, 8 times negative 5 is negative 40. So that's minus 40 equals negative 32. If I add the 40 over, I have 2y equals 8. And so y equals 4. Okay, so now I have solved. I know z is negative 5. I know y is 4. So now I can plug y and z into one of my original equations, and I can solve for x, figure out what x is. So I will just do that. Let me just do that in the middle one here. So I don't know what x is, so I've got 2x minus 4 plus 3 times z, and z was negative 5. So that'll be a plus negative 15 or a minus 15, and it still equals that negative 5. So I have 2x minus 19 equals negative 5. So 2x equals 14. So that means x equals 7. So I have solved the system of three equations. My x value is 7, my y value is 4, and my z value is negative 5. Okay? So that's how you solve a system of equations in three variables. Now we're going to take this same system and I'm going to take it to Desmos, and I'm going to show you how to do Desmos on this. And this is one of those things, it's a little bit different, but it's not too bad as long as you understand how to read what Desmos is asking you to do. Okay, so I'm in Desmos. I'm going to do the same system of equations with three variables that I did on the board. And so when I put these in, I'm going to put them in just like normal, but now I'm going to have three variables instead of two. So if I put these in, I have x plus 2y plus z, and that equals 10. So there's my first equation. Now, when you do this, notice you have an extra variable in there, okay? And when you have that extra variable, you want to tell Desmos to add a slider z. That will help you later. You're only going to have to do that for one equation. but you are going to have to do that, add the slider Z, so that you will be able to tell where these three lines intersect. Okay, so there's your first one. Next thing you're going to do is you're going to click below so that you have another row, and you're going to put the second equation in. 2x minus y plus 3z equals -5. Now notice this time it didn't ask you for the slider Z. That's because you only need one slider. Okay, we'll deal with that later. So that's the only one you're going to need. I'm going to hit enter so that I can enter the third equation. The third equation is 2x minus 3y minus 5z equals 27. So there's my third equation. Okay, now notice it doesn't look like these three equations are going to intersect anywhere. All right, this is something that some students might try and they get confused with linear programming. This is not linear programming. What we're going to have to do here is we have to figure out where all three of these equations intersect. Now mine are green, red, and blue. So I want to know what's it going to take for this blue line to end up intersecting with these two lines. Okay? And that's where my slider comes in. I'm going to go up here to my slider, and I'm going to click on it, and I'm going to start sliding it. Now, when I start sliding it, notice the three lines move, okay? What we want them to do is we want to move those three lines until they intersect at one point. And you can see here, I have them intersecting at one point. So if I click on that, okay, my Z value where those three intersect is at -5. The X value where those intersect is at 7. And the Y value where they intersect is 4. And if you'll notice on your paper, when we did this one by hand, those were the values that we got for X, Y, and Z. X was 7, Y was 4, and Z was -5. But if we hadn't done that one by hand, I'm not sure this would be as easy to understand. So that's why I did it by hand. At this point now, you're going to do Desmos. When you have a system with three equations, just put it in Desmos right off the bat. There's no point in doing these by hand. They're so tedious and there's so much work to them. Just do them on Desmos. It'll make your life a lot easier. Here is a second example of solving systems of equations with three unknowns. So go ahead and jot those down, put those in your notes. And then once you have them written down, go ahead to Desmos and type those into Desmos. Make sure you tell it you want the Z slider for that first equation, and then see if you can figure out where these three lines intersect. So I'm going to put those lines into Desmos. 5x plus 3y plus 2z equals 2. I tell it to add the slider Z. Don't forget to do that. Then I'm going to click underneath for the next line. 2x plus y minus z equals 5. And then enter. And x plus 4y plus 2z equals 16. So those are the three lines you had copied in your note. I notice here it doesn't look like they're converging anywhere, so I need to move my slider Z to see where those three lines will intersect. And let's see, it looks like they're getting further apart there, so let's go this direction, see what happens. Yeah, looks like they're starting to get closer and closer together. So looks like right about there. And if I click on that point, the Z value right here is -3, and the X value is -2, and the Y value is 6. So we've got that system solved. X is -2, Y is 6, and Z is -3.